Installing a floor box in a dwelling with hydronic heating and a Gyp Crete floor requires careful consideration. The issue at hand involves the compatibility of a Hubble cast floor box, designed for concrete floors, with a Gyp Crete and wood construction floor. The Hubble cast floor box is intended for concrete floors with a depth of 3 to 4 inches. Using it in a shallow Gyp Crete floor could lead to structural problems. It is important to consider the manufacturer's recommended depth range. Always consult with a qualified electrician or engineer. Seek professional guidance to determine if the box can be used in the specific floor construction. They can assess the stability and safety of the installation. There are several alternative options to consider. Firstly, surface-mounted floor boxes can be installed on top of the finished floor covering. While not ideal for aesthetics, they offer a viable solution when the floor box is not critical to the overall design. Secondly, in-floor raceways can be installed. These run below the subfloor and connect to a junction box in the ceiling below, allowing access while maintaining the fire rating. Thirdly, a custom-built floor box, made of wood or metal, may be fabricated. This option requires a higher level of skill and could be more expensive. It's crucial to address a few additional considerations. 1. Ensure the subfloor is properly sealed to prevent Gyp Crete leakage. Use a vapor barrier or caulk to seal any gaps around the opening. 2. If you cut the subfloor for the floor box, provide additional support around the opening to prevent sagging. Finally, if the floor box is installed in a fire-rated assembly, ensure compliance with applicable fire codes. Selecting the right floor box involves several key factors. The first factor involves box material. Common floor box materials include metallic and non-metallic options. Metallic boxes, often made of steel or aluminum, offer durability and can provide electromagnetic interference shielding. Non-metallic boxes, typically made of plastic, are corrosion-resistant and suitable for damp locations. The second factor is box shape and size. Floor boxes come in various shapes, including round, square, and rectangular, and a range of sizes. The appropriate shape and size depend on the number and type of devices to be installed, as well as the available space in the floor. The third factor to consider are the number of gangs. The number of gangs refers to the number of separate compartments within the floor box, each designed to house a single device, such as a receptacle or data port. Select a box with the appropriate number of gangs to accommodate the required devices. The fourth thing to consider is the device compatibility. Ensure that the floor box is compatible with the intended devices, such as receptacles, data ports, or communication modules. Check the box's specifications to verify that it can accommodate the device's size, shape, and wiring requirements. Fifth is the floor type. Different floor types, such as concrete, wood, or carpet, require different types of floor boxes. Select a box specifically designed for the floor type to ensure proper installation and secure mounting. Consider concrete floor boxes, wood floor boxes, and carpet floor boxes. Sixth is the ingress protection or IP rating. The IP rating indicates the level of protection provided by the floor box against solid objects and liquids. Choose a box with an appropriate IP rating based on the environmental conditions of the installation location. Consider I-44 rated boxes for splash-proof protection or I-67 rated boxes for dust-tight and waterproof protection. Seventh is the cover and trim options. Floor boxes come with various cover and trim options, including metal, plastic, and carpeted covers. Select a cover and trim that matches the surrounding floor finish and provides a secure and aesthetically pleasing installation. Eighth is the adjustability. Some floor boxes offer adjustability features, allowing the box to be adjusted to the finished floor height. This is particularly useful in installations where the floor height may vary or change over time. Next comes the fire rating. If the floor box is installed in a fire-rated floor assembly, ensure that it is fire-rated to maintain the fire resistance of the assembly. Select a box with the appropriate fire rating based on the requirements of the local building codes. Last is the compliance with standards. Ensure that the floor box complies with relevant industry standards such as Underwriters Laboratories or UL and National Electrical Code or NEC requirements. Compliance with standards ensures that the box has been tested and certified for safety and performance. When working with floor boxes, several safety precautions should be considered. Firstly, always disconnect power before working on any electrical wiring or connections within the floor box. Turn off the circuit breaker or remove the fuse that supplies power to the floor box to prevent electrical shock. Secondly, use appropriate personal protective equipment or PPE such as safety glasses and gloves to protect yourself from potential hazards such as sharp edges, dust, or debris. Thirdly, inspect the floor box for any signs of damage such as cracks, corrosion, or loose connections before beginning work. Replace any damaged components to ensure safe operation. Fourthly, use only approved wiring methods and materials suitable for the environment in which the floor box is installed. Follow all applicable electrical codes and regulations to ensure a safe and compliant installation. Fifth, properly ground the floor box and all associated electrical equipment to provide a path for fault current and prevent electrical shock. Use a grounding conductor of the appropriate size and connect it securely to the floor box and equipment. Sixth, ensure that all wiring connections within the floor box are tight and secure to prevent loose connections which can cause overheating or electrical arcing. Use appropriate wire connectors and tighten them to the manufacturer's recommended torque specifications. Seventh, do not overload the floor box with too many devices or wiring connections, as this can cause overheating and increase the risk of electrical fire. Follow the manufacturer's recommendations for the maximum number of devices and wiring connections allowed in the floor box. Eighth, protect the floor box from moisture and water intrusion to prevent corrosion and electrical hazards. Use a watertight cover and seal any openings or penetrations in the box to prevent water from entering. Ninth, keep the floor box clean and free from debris, dust, and other contaminants that could interfere with its operation or create a fire hazard. Regularly inspect and clean the floor box to ensure proper functioning. 10th, provide adequate ventilation around the floor box to prevent overheating and ensure proper airflow. Avoid blocking or obstructing ventilation openings in the box. And lastly, label the floor box and associated circuits to identify their purpose and function. Use clear and durable labels that are easy to read and understand. In summary, floor boxes provide a convenient and accessible way to bring power, data, and communication services to the floor level. By understanding the different types of floor boxes, installation considerations, and safety precautions, you can select and install the right floor box for your specific application. Surface-mounted floor boxes are enclosures that are installed on top of the floor surface rather than recessed into it. They are commonly used in situations where it is not feasible or desirable to cut into the floor to install a recessed floor box. They offer a convenient and accessible way to provide power, data, or communication services to a specific location. There are several advantages to using surface-mounted floor boxes. The first advantage is easy installation. Surface-mounted floor boxes are typically easier and faster to install compared to recessed floor boxes, as they do not require cutting into the floor. This can save time and labor costs. The second advantage is versatility. They can be installed on a variety of floor surfaces, including concrete, wood, and tile, making them suitable for a wide range of applications. The third advantage is accessibility. Surface-mounted floor boxes provide easy access to electrical or data connections, making them convenient for users to plug in devices or make changes to wiring. The fourth advantage is flexibility. They can be easily relocated or reconfigured as needed, providing flexibility to adapt to changing needs or layouts. The fifth advantage is minimal disruption. Installation of surface-mounted floor boxes typically causes minimal disruption to the existing floor surface, making them suitable for use in occupied spaces. Several considerations should be made when selecting a surface-mounted floor box. 1. Consider the application requirements. Determine the specific power, data, or communication requirements for the location where the floor box will be installed. Consider the number and type of devices that will need to be connected, as well as any specific voltage or current requirements. 2. Consider the size and capacity. Choose a surface-mounted floor box that is large enough to accommodate all of the necessary wiring and connections. Consider the number of outlets, ports, or connectors that are needed, as well as the size of the wiring and conduit that will be run to the box. 3. Consider the floor surface. Select a surface-mounted floor box that is compatible with the type of floor surface on which it will be installed. Consider the material, texture, and thickness of the floor surface, as well as any specific installation requirements or limitations. 4. Consider the aesthetics. Choose a surface-mounted floor box that is aesthetically pleasing and matches the surrounding decor. Consider the color, finish, and style of the box, as well as any available accessories such as covers or trim plates. 5. Consider the safety and compliance. Ensure that the surface-mounted floor box meets all applicable safety standards and building codes. Look for boxes that are Underwriters Laboratories listed or certified and that comply with National Electrical Code requirements. When installing surface-mounted floor boxes, there are some best practices that need to be followed. Firstly, plan the layout. Before beginning installation, plan the layout of the surface-mounted floor boxes to ensure that they are located in convenient and accessible locations. Consider the location of existing walls, furniture, and equipment, as well as the flow of traffic in the area. Secondly, prepare the floor surface. Clean the floor surface thoroughly to remove any dirt, dust, or debris. Repair any cracks or damage to the floor surface before installing the surface-mounted floor box. Thirdly, mount the box securely. Use appropriate fasteners such as screws or anchors to securely mount the surface-mounted floor box to the floor surface. Ensure that the box is level and aligned properly. Fourthly, wire the box correctly. Follow all applicable electrical codes and regulations when wiring the surface-mounted floor box. Use appropriate wiring methods such as conduit or cable, and make sure that all connections are tight and secure. Fifthly, test the installation. After wiring the surface-mounted floor box, test the installation to ensure that it is working properly. Use a multimeter or other testing equipment to verify that the voltage and current levels are correct. Sixthly, label the box. Label the surface-mounted floor box to indicate its purpose and the devices that are connected to it. Use clear and durable labels that are easy to read and understand. The National Electrical Code, or NEC, provides guidelines for installing electrical boxes, including floor boxes. While the NEC does not specifically address surface-mounted floor boxes, it does provide general requirements for electrical boxes that apply to all types of boxes, including surface-mounted ones. The first article to consider is NEC Section 314.27a, which covers outlet box requirements. This section requires that outlet boxes be securely mounted and supported. Surface-mounted floor boxes must be securely mounted to the floor surface using appropriate fasteners, such as screws or anchors. The box must be level and aligned properly to ensure that it is stable and secure. The second thing to consider is NEC Section 314.17b, which covers box fill requirements. This section specifies the maximum number of conductors that can be installed in an electrical box based on the size of the box and the size of the conductors. Surface-mounted floor boxes must comply with these box fill requirements to prevent overcrowding and overheating of conductors. The third thing to consider is NEC Section 314.25, which covers covers and canopies. This section requires that all electrical boxes be provided with a cover or canopy that is securely fastened to the box. Surface-mounted floor boxes must have a cover that is suitable for the environment in which the box is installed. The cover must be durable, weatherproof, and resistant to tampering. The fourth thing to consider is NEC Section 314.40, which covers grounding and bonding. This section requires that all electrical boxes be properly grounded and bonded to provide a path for fault current and prevent electrical shock. Surface-mounted floor boxes must be grounded and bonded in accordance with the requirements of this section. The fifth thing to consider is NEC Section 300.4c, which covers protection against physical damage. This section requires that electrical wiring and equipment be protected against physical damage. Surface-mounted floor boxes must be installed in a location where they are not subject to physical damage from impact, abrasion, or other sources. In-floor raceways are enclosed channels or pathways installed within a floor structure to provide a protected and organized route for electrical wiring, data cables, and communication cables. They are commonly used in commercial buildings, office spaces, and other areas where there is a need for flexible and adaptable wiring solutions. The first benefit to using in-floor raceways is flexibility. In-floor raceways allow for easy reconfiguration of wiring and cabling as needed. This makes it simple to add, remove, or relocate outlets, data ports, and communication connections without the need for extensive demolition or rewiring. The second benefit is organization. They provide a neat and organized way to manage wiring and cabling, keeping them out of sight and preventing clutter and tripping hazards. This can improve the aesthetics of the space and make it easier to maintain. The third benefit is protection. They protect wiring and cabling from physical damage such as crushing, abrasion, and moisture. This can extend the life of the wiring and reduce the risk of electrical hazards. The fourth benefit is accessibility. They provide easy access to wiring and cabling for maintenance, repairs, and upgrades. Removable covers or access panels allow technicians to quickly and easily access the wiring without disrupting the surrounding area. The fifth benefit is scalability. They can be easily expanded or modified to accommodate future wiring needs. Additional raceway sections can be added to increase capacity, or existing raceways can be reconfigured to accommodate new wiring layouts. There are several components that make up in-floor raceway systems. The first are the raceway channels. These are the main channels or pathways that run beneath the floor surface. They are typically made of metal or plastic and come in various sizes and shapes to accommodate different wiring and cabling requirements. The second is the junction boxes. These are used to connect different sections of raceway together and provide access points for wiring and cabling. They typically have removable covers or access panels for easy access to the wiring. The third are the fittings and connectors. These are used to connect raceway channels to junction boxes, outlets, data ports, and other devices. They come in various shapes and sizes to accommodate different wiring configurations. The fourth is the outlet boxes. These are used to mount electrical outlets, data ports, and communication connections within the raceway system. They typically have removable covers or faceplates to provide access to the connections. The fifth are the access panels. These are removable panels or covers that provide access to the raceway system for maintenance, repairs, and upgrades. They are typically located at strategic points along the raceway system to allow technicians to quickly and easily access the wiring. When it comes to the installation of in-floor raceway systems, planning is critical. Plan the layout of the raceway system carefully to ensure that it meets the current and future wiring needs of the space. Consider the location of outlets, data ports, and communication connections, as well as the routing of wiring and cabling. Preparation of the floor is also important. Prepare the floor surface by cleaning it thoroughly and leveling it as needed. Ensure that the floor is structurally sound and capable of supporting the weight of the raceway system. Installation of the raceway channels is a key step. Install the raceway channels according to the manufacturer's instructions. Use appropriate fasteners and connectors to securely attach the channels to the floor surface. Wiring and cabling needs to be pulled through the system carefully. Pull the wiring and cabling through the raceway channels, being careful not to damage or kink the wires. Use appropriate tools and techniques to ensure that the wires are properly routed and connected. Testing and inspection is needed after the in-floor raceway is completed. Test and inspect the raceway system to ensure that it is functioning properly and that all connections are secure. Use appropriate testing equipment to verify that the wiring is properly grounded and that the voltage and current levels are correct. Before you can install any in-floor raceway system, you must consider code compliance. Ensure that the raceway system complies with all applicable building codes and electrical codes. This may include requirements for fire resistance, grounding, and wiring methods. Maintenance of the system is crucial. Maintain the raceway system on a regular basis to ensure that it is functioning properly and that all connections are secure. Inspect the system for any signs of damage or wear, and repair or replace any damaged components as needed. Safety is a must. Follow all safety precautions when working with electrical wiring and cabling. Use appropriate personal protective equipment, such as gloves and safety glasses, and follow all lockout/tagout procedures to prevent electrical shock. When deciding on in-floor raceway systems, there are several things to think about. One is the material. Raceway systems can be made from a variety of materials, including steel, aluminum, and plastic. Consider the environmental conditions in which the raceway system will be installed, as well as any specific requirements for corrosion resistance or fire resistance. 2 is the size and capacity. Raceway systems come in various sizes and capacities to accommodate different wiring and cabling requirements. Consider the number of wires and cables that will need to be run through the raceway system, as well as any future expansion needs. 3 is the access. Raceway systems can be designed with different types of access panels or covers. Consider the ease of access to the wiring and cabling for maintenance, repairs, and upgrades. 4 is the cost. Raceway systems can vary significantly in cost, depending on the material, size, and features. Consider your budget and choose a raceway system that provides the best value for your money. Last is the compatibility. Ensure that the raceway system is compatible with the other components of your electrical system, such as outlets, data ports, and communication connections. Follow the manufacturer's instructions for installation and wiring to ensure proper functioning and safety. Proper sealing of the subfloor is essential when installing floor boxes, particularly in applications where Gyp Crete or similar materials are used. The primary reason for sealing the subfloor is to prevent the Gyp Crete from leaking through any gaps or openings in the subfloor. Gyp Crete is a self-leveling underlayment that is poured over the subfloor to create a smooth, level surface for flooring installation. If the subfloor is not properly sealed, the Gyp Crete can seep through any cracks or holes, causing damage to the underlying structure and compromising the integrity of the flooring installation. Sealing the subfloor can also prevent moisture from penetrating the subfloor. Moisture can cause a variety of problems, including mold growth, wood rot, and structural damage. By sealing the subfloor, you can create a barrier that prevents moisture from entering and damaging the subfloor and surrounding areas. Sealing the subfloor can help to improve energy efficiency by reducing air leakage. Air leakage can cause drafts and make it more difficult to maintain a consistent temperature in the room. By sealing the subfloor, you can reduce air leakage and improve the energy efficiency of the space. Several different methods can be used to seal the subfloor. One common method is to use a vapor barrier. A vapor barrier is a thin sheet of plastic or other material that is applied to the subfloor to create a barrier against moisture and air. Vapor barriers are typically installed before the Gyp Crete is poured and are sealed at the seams to create a continuous barrier. Another method is to use caulk or sealant to seal any gaps or cracks in the subfloor. Caulk or sealant can be applied to the perimeter of the subfloor, as well as to any cracks or holes that are present. This will help to prevent Gyp Crete and moisture from seeping through the subfloor. A third method is to use a self-leveling sealant. Self-leveling sealant is a type of sealant that is designed to flow into cracks and gaps and create a smooth, level surface. This type of sealant is particularly useful for sealing subfloors that are uneven or have a lot of cracks and holes. When sealing the subfloor, it is important to choose the right materials for the job. Use a vapor barrier that is specifically designed for use with Gyp Crete or similar materials. Choose a caulk or sealant that is compatible with the subfloor material and that is designed for use in wet or damp environments. Apply the vapor barrier, caulk, or sealant according to the manufacturer's instructions. Be sure to seal all seams and gaps to create a continuous barrier. Allow the sealant to dry completely before pouring the Gyp Crete. Once the Gyp Crete is poured, Inspect the subfloor to ensure that there are no leaks. If you find any leaks, repair them immediately to prevent further damage. Providing adequate subfloor support around floor boxes is essential for maintaining the structural integrity and stability of the floor. This is particularly important when installing floor boxes in subfloors made of wood or other materials that may be prone to sagging or deflection. There are several reasons why providing subfloor support around floor boxes is important. 1. It prevents sagging. Floor boxes can add weight to the subfloor, which can cause it to sag or deflect over time. Providing additional support around the floor box can help to distribute the weight and prevent sagging. 2. It maintains stability. A sagging or unstable subfloor can create a tripping hazard and make it difficult to install flooring materials properly. Providing additional support around the floor box can help to maintain the stability of the subfloor and ensure that the flooring is installed correctly. 3. It prevents damage. A sagging or unstable subfloor can put stress on the floor box and the surrounding flooring materials, which can lead to damage or failure. Providing additional support around the floor box can help to prevent damage and extend the life of the flooring system. Several different methods can be used to provide subfloor support around floor boxes. One common method is to install additional framing around the floor box. This can be done by adding joists or blocking to the subfloor to provide additional support. Another method is to use shims or spacers to level the floor box with the surrounding subfloor. Shims or spacers can be placed under the floor box to raise it to the proper height and prevent it from sagging. Another method is to use a self-leveling compound to fill any gaps or voids around the floor box. Self-leveling compound can be poured into the gaps to create a solid, level surface that supports the floor box. When providing subfloor support around floor boxes, it is important to follow a few key steps. Firstly, assess the subfloor. Inspect the subfloor to determine the extent of any sagging or damage. Identify any areas that need additional support. Secondly, install additional framing. If necessary, install additional framing around the floor box to provide additional support. Use appropriate fasteners to securely attach the framing to the subfloor. Thirdly, level the floor box. Use shims or spacers to level the floor box with the surrounding subfloor. Place the shims or spacers under the floor box until it is level. Fourthly, fill any gaps. Fill any gaps or voids around the floor box with self-leveling compound. Pour the compound into the gaps and allow it to dry completely. The last thing you need to do is inspect the installation. Inspect the installation to ensure that the floor box is properly supported and that the subfloor is stable. Make any necessary adjustments to ensure that the installation is sound. The fire safety of floor boxes is a critical consideration, particularly in commercial buildings and other structures where fire resistance is essential. Floor boxes can create penetrations in fire-rated floor assemblies, which can compromise the fire resistance of the assembly if not properly addressed. Several key aspects of fire safety should be considered when installing floor boxes. The first is fire-rated assemblies. If the floor box is installed in a fire-rated floor assembly, it is important to ensure that the installation complies with all applicable fire codes and regulations. This may include requirements for the type of floor box used, the method of installation, and the use of fire-stopping materials. The second thing to consider is the fire-stopping. Fire-stopping materials are used to seal any gaps or openings around the floor box to prevent the spread of fire and smoke. These materials are typically intumescent, meaning that they expand when exposed to heat, creating a tight seal that can help to contain a fire. The third thing to consider is the fire resistance rating. The fire resistance rating of a floor assembly is a measure of how long it can withstand exposure to fire. When installing floor boxes in fire-rated floor assemblies, it is important to ensure that the floor boxes do not reduce the fire resistance rating of the assembly. The fourth thing to consider is the testing and certification. Floor boxes that are intended for use in fire-rated floor assembly should be tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or UL. This certification ensures that the floor box meets the requirements of applicable fire codes and regulations. When installing floor boxes in fire-rated floor assemblies, several steps should be followed to ensure fire safety. The first step is to select the appropriate floor box. Choose a floor box that is specifically designed and tested for use in fire-rated floor assemblies. The second step is to follow the manufacturer's instructions. Install the floor box according to the manufacturer's instructions. This will help to ensure that the installation is safe and effective. The third step is to use fire-stopping materials. Use fire-stopping materials to seal any gaps or openings around the floor box. Apply the fire-stopping materials according to the manufacturer's instructions. The fourth thing to do is to inspect the installation. Inspect the installation to ensure that it complies with all applicable fire codes and regulations. Verify that the floor box is properly installed and that the fire-stopping materials are properly applied. In conclusion, installing a floor box in a dwelling where the floor construction consists of a subfloor where hydronic heating is installed and then covered with 1 and 1/2 inches of Gyp Crete and tile for a total depth of 2 inches requires careful planning and execution. While a hubble cast floor box that is exactly 2 inches deep may seem like a viable option, it is important to consider that it is designed for concrete floors with a depth of 3 to 4 inches. Using it in combination with Gyp Crete and wood construction may not be suitable and could potentially lead to structural issues. Consulting with a qualified electrician or engineer is recommended to assess the stability and safety of the installation and determine if the box can be used in the specific floor construction. Alternative options to consider include surface-mounted floor boxes in floor raceways and custom-built floor boxes. Surface-mounted floor boxes can be installed on top of the finished floor covering, but may not be ideal for the aesthetics of the space. In-floor raceways can be installed below the subfloor and connected to a junction box in the ceiling below, allowing access to the box from below while maintaining the fire rating of the ceiling. A custom-built floor box can be created using wood or metal, but this requires a higher level of skill and may be more expensive than other options. Additional considerations include sealing the subfloor to prevent Gyp Crete from leaking through and providing additional support around the opening if the subfloor is cut for the floor box. If the floor box is installed in a fire-rated assembly, ensure that the installation complies with the applicable fire codes. By carefully considering these factors and consulting with professionals, you can ensure a safe and effective floor box installation in your dwelling.